Hello students, welcome to Bstat classes. Today we'll be solving the ISI Bstat question paper of year 2017. Let us start with question number 19. In question number 19 it has been said that we need to consider the function f which goes from r to r and is defined as follows. F of x is equal to x minus 1 into minimum of x or x square if x is greater than equal to 0, or f of x is equal to x into minimum of x comma 1 by x if x is less than 0. In that case, f is differentiable everywhere. Option A. Option B is not differentiable at exactly 1 point. Option C is not differentiable at exactly 2 points. Or fourth option is not differentiable at exactly 3 points. So we need to basically the main part of this problem is to define this x. And upon defining x, we can definitely find out the differentiability at the break points, and then we'll get to know whether the function is differentiable at 1 point, 2 point, 3 point, or is differentiable throughout. Let's find it out. Now f of x is given by this form. Now if for minimum of x and y, first we need to check out the range where x and x square is greater or less than each other. Now if x square is greater than x, so this means that x into x minus 1 is greater than 0. Now if we put it on number line 0 and 1, this will come down to plus, minus, plus. So basically if x lies in the interval, now we know that x is greater than equal to 0, so basically this portion will be neglected. We will only consider our thought in this part. So if x lies between, if x lies with 0 less than equal to x less than 1, then this is given by x minus 1, and in this case the minimum x square is greater than x, so this implies in this interval x square is less than x, so this implies the minimum value is x square, so this will be given by x square for this. Now if x is greater than 1, greater than equal to 1, so this will be given by x minus 1 into minimum value will be x, so this is x over here. Similarly, so this is first part, and the second part will be if x, when is x greater than 1 by x, so this implies that x square minus 1 is greater than 0. This implies that x minus 1 into x plus 1 is greater than 0. So now if we put it on a number line, this will seem like minus 1 plus of 1, this will give a plus, minus, plus. Now we are not considered with, now 0 is somewhere over here, we are not considering this part we don't want to consider. We are only considered with the part which is x less than 0. This is the part which I considered. Now x square x is greater than 1 by x. This is possible when x is less than minus of 1. So the minimum so 1 by x is the minimum value when x is less than minus 1. So if x is less than equal to minus of 1, in that case the minimum value is 1 by x, so that implies that this will be x into 1 by x, and if x lies between minus 1 and 0, then x is the minimum value. In that case this will be given by x into x. So this function upon definition, now let us write this in a piecewise manner. 1 by, when x lies between minus 1 and 0, then the fx is equal to x square. When, let me write this one more time. If this will give that if x is less than equal to minus of 1, in that case fx is equal to 1. If x lies between minus 1 and 0, in that case fx is equal to x square, and if x lies between 0 and 1, in that case this is given by x minus 1 into x square, and if x is greater than equal to 1, in that case this is given by x minus 1 into x. So after finding this function, we need to check differentiability at the breakpoints, and the breakpoints here are at breakpoints. The breakpoints here are -1, 0 and 1, the breakpoints here. So the breakpoints here are x equal to -1, 0 and 1. We need to check differentiability at these 3 points. Let's insert another page. So what we'll do, we'll try to find out f dash of 0. F dash 0. Now f dash 0, we'll see that here left hand derivative is equal to 0, and also right hand derivative is equal to 0. So at x equal to 0, I'm not solving this, you need to solve this yourself. At x equal to 0, f of x is differentiable. Similarly, f dash 1 and f dash minus of 1 also exist. So basically at all the breakpoints, f is differentiable. Now if the function is differentiable at all breakpoints, then f is differentiable everywhere. So this is the option A. So today we will solve question number 19 from the ISI Bstat question paper of year 2017. We will be solving the next questions in the subsequent videos. Till then, keep watching Software's classes videos for more solutions and content. Thank you very much.